Welcome back to Lesson 2 on heat stoichiometry. We're going to be referring to mole to heat ratios, and we're going to do some practice problems. Many thermochemical equations are found on reference table I. Again, that's the heat of reactions, just like this equation, this combustion example. What kind of thermochemical reaction is this? In order to figure that out, you have to locate the energy in the system. This energy is a product. So if energy is a product, then it's going to be exothermic. Just keep that in mind. So this is what this whole equation really means. It's 1 mole of methane and 2 moles of oxygen gas will mix and combust to create 1 mole of carbon dioxide, 2 moles of water, and negative 890.4 kilojoules. Again, it's negative because heat is being released. So just like we did in our stoichiometry unit, we're going to set up a chart with our mole ratios. So these mole ratios are going to help us for our stoichiometry. So here's an example, how much heat is released when 3 moles of methane are burned. Okay, so we're going to understand that these are the two things that we are going to be talking about. We're going to ignore the other pieces because we don't need their information. You set this up in a ratio, and now you just cross multiply. When you cross multiply and divide, you end up with negative 2,671.2 kilojoules of heat. Again, just make sure that this makes sense. If you started off with 1 mole, and you only had negative 890, does it make sense that if we increase the moles of methane, that the amount of heat being released would also increase? Another example, a calorimeter measured 4,452 kilojoules of energy from the below reaction. How many moles of water are created? Let's set up our mole ratios in that chart and plug in the information we know and the information we want to find. So again, everything that is not being used, we're just going to simply ignore it. Cross multiply and divide, and we end up with 10 moles of water being needed to produce 4,452 kilojoules of energy.